So let us see this question. Calculate the amount of aluminium required to get 1120 kg of iron in below reaction. So the reaction is given: ferric oxide plus aluminium gives rise to aluminium oxide plus iron. Okay, so according to this equation, we need to find out 1120, the amount of aluminium required to get 1120 kg of iron. Okay, so first let us write in this equation what are us. We are given a chemical equation. So what shall we do first is, let us write balance this equation. We have to balance, because to solve this type of question, stoichiometric calculation, we definitely needs a balanced chemical equation. So from balanced chemical equation we can get the required quantities, right? First we balance. We have let's write 2 iron atoms here. I'll write 2 iron atoms. Write 2 aluminum atoms here. I'll write 2 aluminum atoms. 3 oxygen, 3 oxygen. It is balanced now, right? Now, so what are mentioned in the question? Calculate the amount of aluminium. So amount of aluminium in terms of its weight. In terms of its weight, we need to find out. So calculate the amount of aluminium required, which means we write what weight, what are the quantities involved here. One is weight of aluminium is asked in the question. Amount of aluminium required to get 1120 kg of iron. So where is iron? It's iron. Weight of iron is given here. So I'll write weight here. Weight of iron and weight of aluminium. So these two quantities are only compared. So remaining part of the equation, after balancing, remaining part of the chemical equation, the reactants and products can be ignored. Our focus must be only on the required things in which are involved in the question. Weight of aluminium, weight of iron. Let's say what weight. First let us write from this we understand 2 moles of aluminium, okay, when react with ferric oxide, producing 2 moles of iron. Okay, right, let's write 2 moles. 2 into how much ton aluminium weight is 27 gram. 2 into 27 grams of aluminium needed 2 into 56 grams of iron, right? 2 into 27 grams aluminium when react with ferric oxide produces 2 into 56 grams of iron. So let's write this is 2 into 27 grams. So this is 54 grams. 54 grams of aluminium produce 2 into 56. It's 112 grams of iron is produced. So 54 grams of aluminium produces 112 grams of iron, right? But what is given weight? 1120 kg of iron. If I write, then 1120 kg of iron needs what amount of, let me take it W, what amount of aluminium. This W we have to find out. Okay, so what we have to do? First thing, we see the question, we write the balanced chemical equation, and then we write what quantities and what substances involved here. Calculate the amount of aluminium. So weight of aluminium is asked and weight of iron is given. So I write weight and aluminium and weight of iron. That two quantities only now considered, and the relation between the two weights are established. I have established here 54 grams of aluminium produce 112 grams of iron when it reacts with excess ferric oxide. Let's see. We don't need amount of ferric oxide and aluminium oxide produced. We only rely on weights. We are weights involved in this question, right? Now this W we have to find. For that, what do we get? W is equal to, we do cross multiplication. What is it now? It's 54 gram of aluminium multiplied with 1120 kg. 1120 kg means 1000 gram. Okay, let me write all weights in grams only. By what weight? These two are multiplied, so that goes, so it becomes 112 grams. Okay, now what shall I do? Let's simplify this, right? Gram and gram get cancelled, any 2 grams gets cancelled, right? 112 ones are 112, tens are here, right? So W is equal to 54, and next what is left? 10 into what left? 1000 gram. 1000 gram. We know this 1000 gram is 1 kg. 54 into 10 is 540. 540 into 1000 gram is 1 kg. Then W is equal to 540 kg. What does it mean? Then we get, what is W? W is the weight of aluminium needed. So we get the answer. What is it? 540 kg of aluminium is required. Aluminium is required to produce 1120 kg of iron. Okay, that's all. This is the calculating weight of iron, weight of aluminium needed for this chemical reaction. Yeah, let us see one more example of calculating amounts of reactors or products using stoichiometric quantities. So the question is, calculate the volume. Let me write V for volume, right? Mass, V here in this chemical equation, sir, mass of the substance and weight are used synonymously. So mass instead of weight I am writing. Number of molecules, let me represent by capital M, capital N, number of molecules, volume and mass of hydrogen. Of what's the substance? Hydrogen liberated when 230 grams of sodium, weight of sodium is given, react with excess water. So let us first identify the chemical reaction involved here. Sodium reacts with excess water to produce hydrogen gas. So let us write the answer for this, right, chemical equation. So sodium reacts with water to produce sodium metal, react with water. It produces sodium hydroxide plus hydrogen. You know, in this question only hydrogen is given, only one product is given. If you write only one product, you will get wrong answer. We have to write a complete equation and that equation should be balanced. Let us balance it. I write 2 sodium, 2 H2O, 2 NaOH and H2. 2 hydrogens, 4 hydrogens, 2 sodium, 2 oxygens, 2 oxygens. It is balanced now, right? And now, what is it? What are involved here? What substance are involved here? So excess water. It is mentioned excess water. 230 grams of sodium react with excess water. Whenever some substance is given excess quantity and that, that enough amount to react with the other substances, so we don't need to worry with the amount of water here. So what is the weight given? What is it? Weight of sodium, 230 grams of sodium. So what is it now? It's weight of sodium. Weight of sodium is given in the question. And we are also asked volume, mass and number of molecules of hydrogen released. This hydrogen released, we need to find out its volume, we need to find out its number of molecules, and also we have to find out the number of the mass, the weight of the hydrogen released. We have to find out these three. Let's find out one by one, right? First, let's find out weight of hydrogen liberated. From this balanced equation, we could write what weight this is. This is 2 into sodium. So which means 2 moles, right? 2 Na means 2 mole. 2 mole. 2 into, what is a molar mass of sodium? 23 gram. 2 into 23 grams of sodium produce 2 gram hydrogen. 2 gram hydrogen. Then what is given weight? 230 gram. Then 230 gram sodium produce what weight of hydrogen? So let us write it as W. This W, let's find out. This W is equal to cross multiply. We write 230 grams into 2 gram by 2 into 23 gram. Okay. Firstly, let's cancel. This gram and gram get cancelled, right? These 2 and 2 get cancelled, right? This 23 and 23 tens are 230. It get cancelled. Then what is the weight here? 10 is remaining. 10 is remaining. What else remaining? Only gram. So 10 gram. So what is the weight of hydrogen? Is 10 gram. So this is weight of hydrogen. Okay. Weight of hydrogen. This is I'm writing hydrogen. 10 gram is required. So weight completed. Weight we found. Then let us find volume. Let's find volume at STP. Second, this let it be number 1. Let's go for second case. What we have to find out? Volume of hydrogen liberated at STP. at STP. So from this balanced chemical equation, you see balanced equation 2 into sodium, like 2 into sodium means 2 into 23 grams. 2 into 23 grams of sodium at STP. What is the coefficient of hydrogen? Only 1, which means 1 mole. 1 mole at STP occupies 22.4 liters of volume, 4 liters of hydrogen. Okay, when 2 into 2 moles of sodium reacts with excess water or sufficient quantity of water, and that produce 1 mole hydrogen. 1 mole hydrogen at STP, standard temperature and pressure, occupies 22.4 liter of hydrogen. But we are given how much amount in the question? 230 grams. If I take 230 grams of sodium, that at STP, same at STP, it what is its volume? Let's say the volume is V. Let's find out this V. Okay, let's do it here. Right, then the V is equal to, we have to cross multiply here. The V is equal to, what happens now? This V is equal, these two are multiplied, 230 grams into 22.4 liter. 230 grams of sodium into 22.4 liter of hydrogen by 2 into 23 grams, right? 2 into 23 grams. So what happens here? This gram get cancelled, right? This 23 ones are 23 tens are, this 2 ones are 2 fives are, right? Then what volume here? Volume is equal to 5 into 22.4 liter. 222.4 times 5. Okay, 5 fours are 20, 5 twos are 10, 12. Right, it will be 12, 5 twos are 10 plus 1, it's 11, right? Then 1, 2. So this is 112 liter. This is the volume of hydrogen liberated here. We get it. Now we'll calculate what is the remaining one? Number of molecules. Let us do it here. From this balanced equation, 2 moles of Na, like 2 into 23 grams of sodium producing 1 mole hydrogen. 2 mole sodium producing 1 mole hydrogen means 2 into 23 grams. 2 into 23 grams. So we need to find, we are only given weight of sodium, so we need to use this weight of sodium, and we need to find out number of molecules of hydrogen, weight and number of molecules. Weight of sodium, let me take weight of sodium, 2 into 23 grams. From balanced chemical equation I am writing this, produces 1 mole. 1 mole means Avogadro number, I already told you, 1 mole hydrogen or 1 mole any substance, not solid, liquid, gas, any substance contain Avogadro number of particles. 1 mole hydrogen gas here, 6.02 into 10 to the power 23 molecules. Then what is a given weight? 230 grams of sodium produce X, let's say X molecules of hydrogen. Then how do we write this X? Let's say what is it? Capital N, number of molecules of hydrogen. N is equal to, I just cross multiply here, same 230 grams of sodium into 6.02 into 10 to the power 23 molecules of hydrogen by 2 into 23 grams of sodium. 2 into 23 grams, right? Now let us cancel this gram get cancelled. 230 ones are 230 tens are, right? 2 ones are 2, 3.01, right? Now let us write the remaining quantities. N is equal to, what is left here? 10 is left into what is remaining? 3.01 into what is remaining? 10 to the power 23. Any other unit is remaining? Nothing. So N is equal to, I'll write N is equal to 3.01, 10 to the power 23 into 10 to the 10 is equal to 10 to the power 24. This is N. What is N? Number of molecules of hydrogen liberated. So this is 3.01 into 10 to the power 24 molecules of hydrogen is liberated when 230 grams of sodium reacts with excess water. Now you see here, we are given 230 grams of sodium reacts with excess water. We need to find out volume, mass and number of molecules of hydrogen found. First we found weight of hydrogen, 10 grams of hydrogen, right? Next volume is found 112 liters of hydrogen, and lastly what number of molecules of hydrogen gas liberated. This is all we found. In this way we can find weights of substances formed from the weights of reactants given using the balanced chemical equation. Balanced chemical equation is also called a stoichiometric equation. So the next question, calculate volume and number of molecules of CO2 liberated at STP. If 50 grams of CaCO3 is treated with dilute hydrochloric acid which contain 7.3 grams of dissolved HCl gas. So for this, first thing, we should not feel tense looking at the question. Very simple. First write the chemical equation, reaction, identify the chemical reaction involved and write the balanced chemical equation for it. For this, CaCO3 is treated with dilute acid. Metal carbonate is treated with acid. Metal carbonate is treated with acid. It produces salt, water and carbon dioxide. Let us write here the chemical equation. I write CaCO3. Right, let's write the answer. Here, CaCO3, calcium carbonate, treated with hydrochloric acid. It produces, we don't know what are the products we are given, only the CO2 liberated, only CO2 is liberated, but along with CO2, other products are also there. Let us write all the products. This is metal carbonate treated with acid, produces salt, water and carbon dioxide, right? What is the salt here? Generally we identify salt, metal from metal carbonate and non-metal from the acid, negative part of the acid, calcium and chlorine. So the salt is calcium chloride, that is CaCl2, plus what other products? Water and CO2. Water plus CO2. This is the chemical equation, right? This is the solid we take. This is the aqua solution, dilute solution, right? Aqua. This is also aqua solution. This is water is liquid and CO2 is a gas. Okay. Actually, this solid CaCl2 dissolves in water, produces aqua solution. This is a complete chemical equation for this change. We have to balance it. Is it balanced? Right? 2 chlorines, 2 hydrogens. We have only 1 chlorine, 1 hydrogen. I'll make it 2 moles. Right, 1 calcium, CO3, CO2 and 1 CO3, 2 hydrogens, right? This is a balanced chemical equation. Now, let us solve one by one. What we need to find out? We have to find out volume of CO2. We have to find out number of moles of CO2 liberated. If 50 grams, weight of W1, let's say weight of reactant 50 grams, and that reacts with dilute acid which contain 7.3 grams of HCl. So weight of HCl is given, let it see W2. Okay, now let us find one by one. In this reaction, first let us write the stoichiometric quantities involving here. This is balanced equation. Let's write CaCO3 weight 40 plus 12, it's 52, right? 52 plus 48, it's 100. Then it is 100 grams of CaCO3, 100 grams of CaCO3, right? We are asked to compare only, like we are given weight of calcium carbonate, weight of HCl and weight of carbon dioxide. So calcium chloride is not required here, H2O is also not required. They are required only for balancing chemical equation. Now 100 grams of CaCl2 reacts with 2 times of hydrogen 1, this is 35.5. 1 plus 35.5 is 36.5. 2 times is 73. 73 grams of HCl. Okay, 100 grams of CaCO3 reacts with completely 73 grams of HCl, right? And produces, what is it? What weight of carbon dioxide here? We need to find out volume and the number of molecules. Let's write. Okay, number of molecules is, this is 100 grams, this is 70 grams. Let us write what is it, Nana? This is only 1 volume. Let's write the coefficient is only 1. We understand it is 1 mole carbon dioxide. 1 mole contain 1 Avogadro number molecules or 22.4 liter of CO2 at a STP. So let me write it here. What is involved? We need to find out the volume and also we need to find out the number of molecules. Okay, and from this balanced chemical equation, since it is only 1 volume, 1 mole, this is 1 mole, right? 1 mole, and this 1 mole, it at STP it occupies 22.4 liters of volume, and number of molecules, 1 Avogadro number, which is nothing but 6.023 into 10 to the power 23 molecules of CO2, right? These are the quantities we compare. Okay, now let's see. But we are given here 100 grams, let us understand, 100 grams of CaCO3 needs 73 grams of HCl for completely reacting and produce 22.4 liter CO2 and Avogadro number of molecules, carbon dioxide molecules, right? But what are the given weights? This weight is given only 7.3 gram. This weight is given 50 gram. Okay. Now from balanced chemical equation, I'll write here, from balanced equation, what do we say? We write 100 gram CaCO3 require 73 gram HCl, hydrochloric acid. But what weight of calcium carbonate is given? It is given 50 gram. Then 50 gram CaCO3 means half of the given weight, 100 gram, and the weight given is exactly half. Then 50 gram CaCO3 needs 73 half is how much, Rana? 36.5 gram HCl. Yes or no? Right? Then this is the condition. Okay, 100 grams of CaCO3 needs 73 gram HCl. This we found from balanced equation. Then 50 grams of calcium carbonate needs 36.5 grams of HCl. But 50 grams of CaCO3 is given, it's okay. But are we also provided 7.3 grams of HCl? Are we given 36.5 is needed? But how much we are given? Only 7.3 gram. Are you able to understand? 50 grams calcium carbonate needs 36.5 gram HCl. But we are given only 7.3 gram. Is it more than enough or less than enough? We understand is less than enough. We need 36.5 gram to react completely with 50 gram CaCO3. But we are given only 7.3 gram. It is less than required. Less than required. We require this, but this is only less than required. So what is given less than weight of dissolved HCl gas? This weight we are given, but I am writing here, but we are given only how much we are given? 7.3 grams of HCl. Okay, in this CaCO3 is one reactant, HCl is another reactant. 50 gram CaCO3 is given and that needs 36.5 gram HCl, but we are given only 7.3 grams. And this reagent, reactants are also called reagents, and this reagent that is less than required quantity, then it is called limiting reagent. Such reagents are called limiting reagent. So this limiting reagent decides the amount of products obtained, because you see 50 grams of CaCO3 needs 36.5 gram, then 7.3 grams of HCl needs only how much, Rana? It's only 10 grams of HCl out of given 50 grams of CaCO3. Only first 10 grams of CaCO3 completely reacts with 7.3 grams of HCl and remaining 40 grams. Okay, for this 7.3 gram, only 10 grams completely reacts, 10 grams of CaCO3 reacts, remaining 40 grams will be unreacted. 40 grams will be unreacted. So this unreacted substance cannot decide the amount of products, only the required one. So that means 7.3 gram HCl decides the amount of products. Now let us see this, since what is limiting reagent? HCl is the limiting reagent and that decides the amount of products. Now we write from the balanced equation again. From balanced equation, 73 gram HCl, what is excess substance here? Excess amount is CaCO3. 73 grams of HCl reacting with 100 grams of CaCO3 or excess CaCO3 producer, how many, like what volume at STP produce 22.4 liter of CO2 at STP. I hope you are getting. 73 grams of HCl, 73 gram HCl producing one volume. One volume means 22.4 liter at STP, okay, of CO2 is produced. Then what is the given amount? Only 7.3 gram. Then 7.3 gram HCl produce what volume of CO2 at STP? So we'll write V is equal to 7.3 gram into 22.4 liter by 73 gram. So what do? I just cancel this gram, first units get cancelled, then 7.3 ones are 7.3 tens are, then what is remaining? V is equal to 22.4 by 22.4 by 10 liter, which is equal to 2.24 liter of CO2 at STP is liberated. Okay, this is an important question where we understand the concept of limiting reagent. Okay, the reagent or the reactant which is less in quantity, less than required quantity is limiting reagent, and that decides the amount of products. Then the limiting reagent quantity is compared with the required one. So to get the answer, this is 1. We get volume, how much? 22.4 liter of CO2 is 2.24 liter of CO2 is obtained when 7.3 grams of HCl react with excess CO2. And now what we have to find number of molecules. Then from balanced equation, again I'm writing from balanced equation. What do we write? You see this balanced equation. How much is it? 73 grams of HCl. 73 grams HCl produce how many moles of CO2? 1 mole of CO2. 1 mole CO2 contain Avogadro number of molecules. I'm writing 6.02 into 10 to the power 23 molecules of CO2. Then we are provided only 7.3 grams of HCl. 7.3 grams of HCl provide what number of molecules of CO2? Then let's find X. X is equal to number of molecules of CO2. X is equal to, I write 7.3 grams multiplied with this 6.02 into 10 to the power 23 molecules divided by 73 gram. Now what do? I just cancel gram and gram. 7.3 ones are 7.3 tens are, right? Now I write this X is equal to 6.02 into 10 to the power 23 by 10. X is equal to, okay, we write it as 6.02 into 10 to the power 23 into this 10 goes upside, becomes 10 to the power minus 1, and this answer is equal to, when bases are same, powers are added, 23 minus 1 is 22. So we write 6.02 into 10 to the power 22 molecules of CO2 is produced. Okay, this is answer. I hope you understand solving this problem. Okay, here we compared the amount of CO2, the volume of CO2 released, number of molecules of CO2 produced, only with the weight of HCl gas, not with weight of calcium carbonate. It is because, you know what, 50 grams of calcium carbonate needs 36.5 grams of HCl, but we are provided only 7.3, less than required quantity. So that reactant which is provided less than required quantity is called limiting reagent, that decides the amount of products obtained. So we compare this at the quantities required with the amount of limiting reagent given. Okay, so in such questions, always compare the required quantities with only quantity of limiting reagent to solve these questions. Okay.